With a camera obscura, you can project an image of a scene onto a piece of paper and trace over the projection to create a realistic, detailed drawing. This is what artists in the 17th and 19th century used the camera obscura for. As you have already learned from our blog how to build your own camera obscura, we are now going into more detail about the physics of the camera obscura. Here you can see an open camera obscura. But why is the image of the scene not projected onto our piece of paper?
This question can be easily answered. Light rays bouncing off the subject will not form an image because rays of light travel in straight lines and therefore they will strike the wall in many different places. The inside of our camera obscura with the paper on it will be hit by reflected light, but there will not be a focused image. In order to form a focused image, one needs to make sure that the light reflected off each point on the subject will only hit one point on the wall beyond, which is the wall with the piece of paper. This can be done by placing a wall with a pinhole in the middle of it between the subject and the wall with the piece of paper. If one then allows no other light to hit the wall, in this case by taping any ribs and joints of our box, an image will be formed.
The bigger the pinhole is, the less sharp the image becomes, because rays from each point on the subject hit more than one place on the wall with the piece of paper. When adding a lens to the camera obscura, a sharper and larger image can be obtained because more rays from each point on the subject can hit one place on the wall with the piece of paper. A lens is a molded piece of transparent material that refracts light rays and forms an image. But how does light pass through a lens and form an image? A ray of light is refracted at two boundaries, at the front face of the lens as it enters and at the back face as it exits. At these boundaries of the lens, the light ray changes its direction and its speed, since air is less optically dense than the glass of the lens. The picture you see on the screen of our camera obscura is upside down, since light travels in a straight line. Rays from above the pinhole pass through it and hit the bottom of the wall opposite, which is the piece of paper in our camera obscura. Rays from below the pinhole, however, end up at the top of the piece of paper. A sharp upside-down image can be seen. But why doesn't the image on our piece of paper have much color?
The answer to this question is that the retinas in our eyes have two types of receptors, rods and cones. Rods are much more sensitive, but they only register light and dark. Cones, in contrast, allow us to see color, but they need more light in order to work. Since the pinhole only allows in a small amount of light, the picture is primarily seen with our rods, and thus largely in black and white. You now successfully gained more background knowledge regarding the camera obscura and its physics.
Will be hit by reflected light, but there will not be a focused image.
Oh my gosh, centuries used the camera obscura for. As you have, du musst es schon lange abbiegen.
Entschuldigung.
As you have already learned from our blog, how to build your own camera to our piece of paper. But why is the image of the scene not projected onto our piece of paper? Oh, Moment, auf mit der Pause.
Das muss ich jetzt, oder?